Sound waves, Physical Sciences Grade 10. How is it possible that you can hear? Have you ever asked yourself that question? For example, how is it possible that you can hear a friend greeting you from a distance? A tada. We hear the sound they make, right? But how does the sound they make travel to you so that you can hear it? Before we can even hear the sound that they make, how are they even able to make that sound in the first place? It's amazing that we can hear so many different kinds of sound and determine where they come from. In this lesson, we will talk about sound and answer all these questions I have just asked. At the end of this lesson, you will be able to define sound as a longitudinal wave, explain the relationship between wave speed and the properties of the medium in which the wave travels, such as a gas, a liquid, or a solid. Describe echoes as reflections of sound waves. Humans have a voice box. Well, there's a more sophisticated way of describing a voice box, but that is a topic for biology. We are more interested in the physics. The voice box is located somewhere in your neck. Inside this voice box, there are things called vocal cords. When these vocal cords vibrate, they make a sound. Sound is caused by vibration of the medium. But what causes these vocal cords to vibrate in the first place? The air from your lungs make the vocal cords vibrate, and in turn, this is what causes the sound. So, the air from your friend's lungs causes their vocal cords to vibrate, and in turn, they can make a sound, a tada. But how does the sound travel to you? How does the sound reach you? The vibrations push the air particles in front of your friend's mouth, causing them to also vibrate. As the air particles vibrate, they move from equilibrium, because they were initially at rest, pushing the particles in front to form a compression. Then the particles return to equilibrium. As they return to equilibrium, they form a rarefaction. Then the next particles will form a compression, followed by a rarefaction. This will happen until the sound reaches your ear. So there's this pushing of the particles in the direction in which the sound is directed. The particles keep pushing, then going back, then the next one push, then they go back, then the next one push, 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 push until they reach you. Now, a wave that has regions where the particles are closer together, called compressions, where they are pushing against each other, and regions where the particles are far away or are far apart, called rarefaction, is called a longitudinal wave. This tells us that sound is a longitudinal wave. As the particles continue to push against each other, the sound travels through the air. A compression is a region of high pressure where the particles are closer together in a longitudinal wave, and a rarefaction is a region of low pressure where the particles are far apart in a longitudinal wave. Sound, therefore, is a longitudinal wave consisting of these compressions and rarefactions. This longitudinal sound wave reaches your ear and causes your eardrum to vibrate, which is how you can hear. Sound waves are caused by vibrations in the medium in the direction of propagation. The vibrations cause a regular cause regular changes in pressure in the medium. A sound wave is a longitudinal wave. Sound waves are pressure waves, meaning they need a medium through which to travel. Sound waves can travel through a gas, a liquid, or a solid substance. Sound waves travel faster through liquids than through gases. This is because liquid is denser than gas. The particles in liquid are closer together than in a gas substance. Sound waves, however, travel faster in solids than in liquids. This is because the density of solids is higher than the density of liquids, which means that the particles are closer together and sound can therefore be transmitted more easily. The denser the medium, meaning the closer the particles of the medium are, the faster the speed of sound. Density of the medium increases from gas to liquid to solid, and so does the speed of sound waves. How close the particles are, the density increases as we move from gas to liquid to solid. The denser the medium, the faster the speed of sound in that medium. The table on your screen shows a comparison of the speed of sound in a solid object, that is a brick, a liquid substance, that is seawater, and a gaseous substance such as air. The speed of sound in a brick is about 6,420 meters per second. The speed of sound in seawater is about 1,551 meters per second. The speed of sound in air is about 331 meters per second. The speed of sound is fast in a solid object and slower in a gaseous object or substance. This is because of the density of the material. How closely packed are the particles of a medium in a given volume. The denser the substance, meaning the closely packed the particles are, the faster the speed of sound. Have you ever been in an empty house and you screamed out your name, Tandi? Within a split second, you can hear the same sound you made back. The sound you hear is called an echo. Sound waves are reflected by large, hard surfaces such as building walls or cliffs. This means as you scream, the sound wave is directed towards the wall where it is reflected and travels back to you and you are able to hear it. This reflected sound is called an echo. You can also hear your echo outdoors in wide open spaces with large reflecting surfaces nearby, like if you're standing near a mountain cliff in an area where there's none or very little trees or bushes. In the upcoming videos we'll deal with calculations involving echoes, as these echoes are very useful property of sound waves and you will just see how useful they are. Sound waves are a very interesting topic to study because we hear sounds all the times all around us. Without sound, you would not be able to hear me right now. We have learned that sound is a longitudinal wave with regions of high pressure where the particles are closer together and regions of low pressure where the particles are further apart. The regions of high pressure are known as compressions and the regions of low pressure are known as rarefactions. We have also learned that the speed of sound differs depending on the medium it is traveling. The denser the medium, the faster the speed of sound. And sound waves can be reflected by large surfaces and be heard back. The reflected wave is called or is known as an echo. In the next video, we will solve problems involving echoes.